Okay, as we go into topic 10.5, we are doing what is called rationalizing the denominators. So you see these numbers in the denominator are irrational. So we want to rationalize them. That is, make them a rational number. So the word is very appropriate. An irrational to rational. Now we're looking to make this one, and again we can multiply anything by 1, but this one will be, our 1 will be in the form of the square root of 7 over the square root of 7. Now you might wonder, what do I multiply? Well, there's a little bit of judgment there, but we want to pick up on a number that would make it the smallest denominator. So in this case it is 7. This is the square root of 49. Square root of 49 is 7. And this becomes the square root of 21. Again, we're going to multiply this by the square root of 11. So our numerator, square root of 11, our denominator, just 11. And the thinking behind this is the square root of 11 times the square root of 11, which is equal to the square root of 11 squared. And remember, our index number is 2. 2 divided by 2, you take away the radical sign, just becomes an 11. All right, here it's not quite multiplying it by this because of the third root. Now, you want this denominator to become eventually a 3. So what would that be the cube root of to give you a 3? And that would be the cube root of 27. So what do I have to multiply this one by now to make it 27? Well, the cube root of 9. Remember, multiplying by the cube root of 9 divided by the cube root of 9 is multiplying it by 1. But now this makes this the cube root of 27. And this is still just plain 2, the cube root of 9. So the cube root of 27 is my 3, and my numerator is 2, the cube root of 9. Okay, going on to this one. Now notice y is already a perfect cube. Perfect square. So we're going to multiply that by the square root of 5. And this by the square root of 5. So this then becomes the square root of 25, y squared, which becomes 5y. And my numerator is, I believe, square root of 70x. Number 5 is a little twist on this one where our index number is 3. So we're looking to multiply this by something to make it a perfect cube. Well, it's already at 9. So 3 times 3, we need one more 3 and one more x. So again, we're multiplying something by 1 in the form of something that will rationalize the denominator. So this is going to become 27x cubed. Cube root of that is 3x. And then this becomes the third root of 12x. So these were sort of easy. A little creativity with the cube root. But now we're getting to something a little bit different. here we now have a binomial in the denominator. So to rationalize binomials, we have to multiply them by their radical conjugate, we call it. And what is the conjugate of this? Well, as you recall, it's the same items, but the opposite sign. And what happens when we do that? Well, when we do that, we don't get a middle term and we take care of our radicals here. So our denominator then will be 1. 1 times 1 is 1. Minus, this is going to be the square root of 9. Square root of 9 is 3. So 1 minus 3 is our new denominator, which is going to be a negative 2. So let's put that there. And then this just becomes, in fact, in some cases you can leave it this way, because watch what happens. In fact, let me write it out over here. Can you see now we can cancel here? This will go 1, and this will go 4. And we can put our negative sign now up on top, because we don't like to leave a negative 1 in the denominator. So we'll make that positive, make that negative, and now we can multiply through. This becomes a negative 4 plus, well, in this case, it's going to be a let's write that here. And this is my answer. Negative 4 minus 4, the square root of 3. Okay, we'll check that over. Okay, on these, what I want to do is some of the thinking involved, and maybe that'll help. So, third root. Now here we have a 4. So can you see there's a 2 times 2 there? So to make that 4 a perfect cube, we just have to multiply it by 2. And this x, to make it x to the 4th a perfect cube, x to the 2nd, which will make this x to the 6th. And just one more y. In number 8, here we have a binomial, so we have to multiply it by its conjugate, the square root of x minus 3 and in number 9, again, multiply it by its conjugate, and I probably should change color. Again, you want to multiply each term by 1 in the form of something that will cause the denominator to become from irrational to rational. And the conjugate here as well. So there's lots of little things to do. So what we get here now is 4 times 2 is 8. The cube root of 8 is 2. Now we have x to the 6th, cube root of x to the 6th, x to the 2nd. Y to the 3rd power, the cube root of y to the 3rd is y. So we have rationalized this denominator. And then now we just do this. So this will be the cube root of 6 times 2 is 12, x squared y. In number 8, we have the square root of x times the square root of x gives you the square root of x squared, which just becomes x. And then a positive 3 times a negative 3 is a negative 9. And our top, we could just leave it this way, but we'll multiply through. Negative 2, the square root of x, plus 6. Sometimes they leave this in factored form on top, but this is good too. All right, now our denominator here, this will be the square root of a squared, which is just a, minus the square root of b squared, which is just b. So again, we've gone from an irrational form to a rational form. We have rationalized the denominator. And notice this becomes square root of a squared, which is a, plus the square root of ab. This one's a little tricky, because as you FOIL this, it's 4 times 4 is 8. Square root of 2 times the square root of 2 is the square root of 4, which is 2. So 2 times 8 is 16. So once again, 4 times, well, let me go here again. 4 times 4 is 16. 16 times 2, actually. It's 16 times 2. This will be 32. I stand corrected. And this is going to be minus the square root of 36, which is 6. So this bottom will become 26. This is going to become 26. Now our top, as we FOIL it, this gets a little challenging. Let's just do it slowly. 3 times 4 is 12. 12 times 2 is 24. So 3 times 4 is 12. The square root of 4 is 2. So 2 times 12, 24. Now my outers will be 3, the square root of 12. We're going to have to do something with that. My inners is plus 4, the square root of 12. Again, we're going to do something with that. And then we have the square root of 36, which is 6. Now, remember from before, we said the square root of 12 was the square root of 4 times 3. And the square root of 4 is 2. So here, this is going to become 2, the square root of 3, and so will this one. 2, the square root of 3. The square root of 12 becomes 2, the square root of 3. And then now we can combine things with the magic of marker pen. This is going to become a 6. This is going to become an 8. And now we have sort of like terms. So 24 and 6 is 30. And let's see, I can put it down here. That's over 26, we said. So 24 and 6 is 30, plus 14, the square root of 3. But, again, that's a pretty good answer. We did lots of stuff. We could factor out a 2 from up here, and this becomes then 2 times 15 plus 7, the square root of 3, all over 2 times 13, which is what 26 is. And then our 2's cancel out. And what we have here then, I'll put it in blue, is our best answer. Lots of stuff going on. And not to forget the numerator, here we're asked to rationalize the numerator. I know when I was doing some practice, I was just on a merry spree and I got it wrong and I said, oh, I got this right, how come? And I looked at it and I said, oh, they changed the instruction. Instead of rationalizing the denominator, they were saying rationalize the numerator. Well, everything's the same. You're still going to multiply something by 1. But now you want the numerator to be rationalized. So for this one, it will be the square root of 5, square root of 5. Now this is the 4th power of something. So what do we see here? Well, 27 is a perfect cube. So all we need to multiply that by now is 3. And that'll rationalize our numerator. And then here, all we need to multiply the numerator by is the square root of 3. And then here we have to remember to multiply the numerator by its conjugate, which will be the square root of 12 minus, or plus I should say, the square root of 2. And then the denominator by the same. So a common error that students make is they'll multiply it by the same thing, not its conjugate. Remember, the conjugate is the opposite sign. These terms are the same. So this one is just going to be 5 over 5 times 13, which I believe is the square root of 65. And this will be the 4th root of 81, which is the is 3. And then it will be 3 times 8 is 24. 3 times 4 is 12, and 2. Now I noticed 144 is a perfect square. That would be 12, but 12 is not a perfect square, so I don't believe that one can be anymore. And this will be 3 x to the 7th over 4 the square root of 3. And this one is going to be 12 times 12 is 124. Square root of that is 12. Minus 2 for the top. And for the bottom is 3 times 12 is 36. Square root of 36. Let's write that out. We know that can be simplified. My outers are plus the square root of 6. My inners plus the square root of 24. And I know we can do something to that. And this is just going to be plus 2. So we have some room over here. The top, 12 minus 2 is 10. We can start simplifying the bottom. This is going to be 6 plus the square root of 6. Now the square root of 24, recall, is the square root of 4 times the square root of 6. Oh, I see we're going to do something here. The square root of 4 is 2. So this becomes 2, the square root of 6, and then plus 2. So 6 and 2 are 8, so we have 10 over 8 plus, remember there's one of those, so that would be 3, the square root of 6. If this were a 4, we could factor out something and then do some canceling, but I think that's about as far as we can go. And it never hurts to check your answer for number 18. Remember, the answers are here, and that's a good one. Okay.